Hey guys, welcome into our webinar today. Our webinar will be start at 1 p.m. Singapore time. So stay tuned, and we'll be having our three guest speakers and our senior software engineer from PinCap be sharing today. Hey guys, welcome to the webinar today. Our webinar will be started within 1 minute sharp, so stay tuned.
Hello. Welcome everyone. And what's up, developers? Good morning, good afternoon, and good evening. I'm Chiswang, a developer just like you. In this show, I focus on ecosystem development and advocacy. I'm thrilled to be a host today. Database as a relational database has been booming in the AI sense. We had a large proportion of clients in AI session. We've also teamed up with thousands of users to pull off AI-related projects. So today, we, along with three other guests, would like to share our experiences with you about how we revolutionize tech project with TidyBee. They are Bai Huan Chen, Technical Director of the Linux China Open Source Community, Li Chenpei, founding member of Chroma, the AI native open source embedding database. Sida, the founder of the CrowdSnap, an AI-powered customer research platform. After each speaker, we will have a Q&A session, so feel free to drop your question in the Q&A box. Besides, I will show you a demo, build a GPT's third-party marketplace. To top it off, our product manager, Shi Xing, will test a new TidyBee AI-related feature at the end of the event. Stick around, we won't want to miss it, right? So all of this webinar will be recorded, so if you missed it, you can find it on our official channel again. So Over next couple of years, we're going to witness something extraordinary. So as the cost of the big models has drastically dropped, every one of us now could freely use the GPT, right? Even the advanced version, it takes less than $20 per month. So then what's the next truly value assets from my perspective is the data. So then what's most important for data? A great database. A reliable and highly scalable database should provide real-time analytics capability to deploy AI applications, specifically RAG application. So without further ado, well, I'm so scared. So without further ado, let's see a practical example by how to design and implement a simple retrieval augmented generation application from Bai Huan Chen, Technical Director of the Linux China open source community. Welcome.
Thanks for host. I will try to share my slides. Can everyone see my slides?
Yep, I can.
However, I'm Bastoni from Linux.cn. This topic I'm sharing today is how to design and implement a simple retrieval augment generation application. And I will introduce some of my own experience for building RAG applications, help you under what RAG is, and implement the simplest RAG application. My GitHub ID is Bastoni, and today's slides you can visit simplerag.as.dive to get it. You can find me at Twitter or GitHub. Now let's begin our official content. The simplest generation application is ChatGPT. User open ChatGPT, enter what they want to know, and ask the questions they want to ask. Then OpenAI generates the most likely answer based on calculations and return it to user. In this sample, US presidents is the prompt, and which can help AI understand what you need and calculate the specific context. And OpenAI return Joe Biden to user. Then user say, ChatGPT say Joe Biden, and user say, wow, amazing. When a developer wants to add a specific style to their generated results, the prompt says they send it to OpenAI will add their own style descriptions, such as asking OpenAI to respond to users in what styles. The OpenAI say a more complete prompt and responds with specific information according to the constraints inside the prompt. In this example, developer make OpenAI know, hey, it's Joe Biden, and let OpenAI return, hi, I'm Joy. User will see the results constrained by the developer. OpenAI will return the result according to the rules constraints in the prompt by developer. By modifying the prompt, developer make OpenAI return results have their own desired style. Actually, there's our normally said the ChatGPT, the generation application. What happens if we ask a large model what happened today? The large model doesn't train in real time, so it doesn't know what happened today. When asked it about what happened today, the large model didn't know what real happened today, but it will choose to calculate the possibility answers from its context. However, because the context was already conformed, the large model's responses seem like nonsense. You can use RAG method to solve the nonsense of large models. A system that doesn't use RAG method can use local data and cannot use local data and can only use model training data. Its answers with are often irrelevant with real-life problems. However, RAG application can solve this problem by providing local data context and by giving more context to large models to help large models achieve computations use the latest context. So let's talk about why RAG can solve this problem. If we if we think that content trained in the model is the long-term memorized, then the content we pass in the prompt is the short-term memorized. In systems that don't use RGG method, we only rely on the long-term memories of the large models itself for generation, which always no sense, because it only has the pre-trained data without the time sense data. However, after use RAG method, you can track some context for local time, local data as a short-term memorized, so that the large model can directly use this short-term memorized to complete for us, and we will get a better content. In RAG method, you can directly put relevant content in the prompt so that the large model can use prompts to generate relevant content. This is just like when we're facing an exam. If you use a non-RAG system, means taking the exam directly and relying on our own memories to answer the question. You have a certain probability of answer the question correctly, but there is also a high probability of not remembering the answer to the questions and answer them incorrectly. However, the logic of RAG system is directly bring the book for the exam question into the exam room, and you can answer the question better by reading the book and write the answer. That is why RAG can help us solve the nonsense. Next, let's take a look at what the workflow of a simplest RAG application look like. First, the user sends its query or its prompt. Next, the program will try to query some relevant data from the database. The database can be a standard circle database such as TiDB, or non-standard database such as vector database or timescale database. We will talk about vector database later, but now we just talk about a standard database. If you use the traditional standard database, just like TiDB, you also need ability of natural language to circle, which mainly converts user natural language into circle. After the query from database, we can build our prompt and with the query and the database content. Then we send it to large model and generate a response. And we will get the new response with our local data. User will receive this response with local data and get the better content. To help you under RAG, I have designed a restaurant GPT to use a restaurant as an example. In this story, a user asks a restaurant, a smart assistant, which is the best dishes is. At first, the user say, what is the most popular dish? Then the program try to use natural language to circle to fetch relevant content from database, just like fetch all dishes and all orders. Next, the program will encode the query and content into the prompt, just like use natural language to describe the dishes and the orders relation and put it into the prompt. Build the full prompt. Next, send the full prompt to OpenAI's API, let large model generate a response. And at last, user will receive the response, get dish 2 is the most popular. This is the simplest RAG applications results to how to build a simplest RAG application. RAG application make our RAG method make our application smarter by equipping the know-how with local data with industry knowledge. The above is a simplest example about how we build a RAG application with a standard circle database. Next, let's talk about another example. Use vector database, just like people say in other application. I try to define a same GPT example like named PDF GPT, just like our just like people know ChatPDF, you can have conversation with a target PDF text. User will send a query. What is the key information in this PDF? And we will fetch relevant content from the knowledge base. Also, this is just a simple example. We will try to explain it next. After we travel relevant passage from the base, we will encode all our query and passage into a prompt and send it to large models. Let large models generate a response, and we will receive the response. The key information in this PDF is something. Here we use a vector database to save our PDF's text. And this because we can find it from our knowledge base because similar text will be closed in the vector database. So we can put our natural language into the vector database and try to find the most relevant content from our vector database. So we don't need to use natural language to circle to query data like a circle database. It's more easier for most sense, but in some sense, use natural language is the best choice. There is another process we need to be understood here, which is vector the PDF and how we store this in our knowledge base. At first, if someone uploads a PDF document, we will use the PDF parser to parse the full PDF document. And we will extract the raw data, raw text, using a text extractor and segment text into some paragraphs. After we get the paragraph, we will try to save it into the knowledge base. We try to process the paragraph text with a word processing, just like a tokenization. And we will encode our paragraphs into vectors with an encoder and index our paragraph for next retrieval. After we store all our encoded paragraphs in the knowledge base, we can use just a simple query to try to get the relevant passage from our knowledge base. For this is a simplest the vector database query RG application simple for help you to know how can I check a ChatPDF like application or RG application just to do the same things. The first, try to get local data context from your own database, your own context in application system. Then let the local data into a prompt and send the prompt to ChatGPT to get the better response. It will make your application has local data and just like know-how. All above this is the contribution. Maybe it's short, but thank you for your time and let's move to Q&A if someone has questions.
All right, bye. That was amazing. Yeah, this part is very short, but that was amazing. And I can't wait to build my own RAG application with PyDB after this session, So thanks for sharing, Bai. So let's have some questions from the audience. So I already got one. So one of our audience asked, how long and how many people does it take to develop a RAG application?
Okay, just in my slides, build a simple RAG application is not need many developer and need more time. You just have your own data and try to build how to fetch data from database. You just need to teach OpenAI to generate a circle from your database shared field, and you can use this to fetch data from your database. After build a basic fetch data function, then you just need to build your prompt and send this prompt to OpenAI, and you will get the result. Actually, I think it needs to just with the service with some service just like Vercel, like TidyBit serverless and Langchain as a framework, you can build a RAG application within 1 week. It's not too hard for people who know. RAG is not hard. It's just a simple method to achieve your target.
Oh, okay, okay. Just 1 week. Oh, that's so impressive. So yeah, I got it. I got it. So, all right, any questions? If no, I already saw the Q&A. So the next one would be demo would be on Stanford. So it's another question. And the next, yeah. So from the James, when using a multi-language app, is it better to create a local knowledge-based content on each languages, or can we trust the LM to output correctly regardless which language is used? Like if you want to build a knowledge content, for example, the Chinese and the English, would you prefer to use Chinese build the Chinese like the languages content, or use English can transfer to Chinese? Does it, depends, or it's just like the same thing?
I know it's actually I think you don't need to build the different knowledge base for
Mm-hmm.
each language, but it depends on which sense for you. For example, if you build an application just English and Chinese for this common language, you can use the simple and single knowledge base and let OpenAI translate it to the target language. But if you use Japanese, you maybe build a Japanese database for you, because the OpenAI translate English to Japanese is not clear and is sometimes have no sense. So just like what your customer has, if they speak Chinese or English or something ChatGPT can easily translate, it's okay. But if your customer use the language is a small market, maybe you need to build maybe you need to build a single database for this.
All right, got it. So maybe the Chinese and English, they have a lot of the materials, but Japanese don't have a lot of materials, so they cannot, translate very well. So
Yes.
maybe that's why. Okay, okay. So next question would be, can you please explain what does the pipeline looks like for what happens after you have a rack to get the deployment? Please discuss things like containers and Docker, etc. Like that.
For me, I didn't try to use containers and Dockers because I like to use RH. I like to build some application more slightly. I just like use just like Vercel. I use Vercel for my hosting web page. Just like use the simple rag.ai starter.dev. The website is deployed. Use Vercel. And if you use database, you don't need to deploy it by yourself. You can use just like a TidyBit serverless or other serverless database. And the next is just use this. Don't need to deploy container. And as the AGI application, you need to use more time to build application and use less time to the architecture to Docker or container is not the main question. Your main question is who is my customer and what content they want. You need to find the content and give it the content. The container, the Docker, and our technical skill is just an inside question, but we try to solve the market question. So I think you can use everything you just like, or just you can easy to use it. Build fast, feel fast, and let the market get it.
Got it. Got it. Yeah, totally makes sense. So maybe the data and the database is the fundamental part of the LLM, but maybe you can deploy anywhere like Docker, Kubernetes or whatever you want, actually. So got it. And I think the time is running up. So thanks, Bai. And if you, the audience, if you have any questions, you can reach out to Bai through his social media accounts. So thanks, Bai. And we will go into the next. The next is a speaker that a lot of people in this webinar are familiar with. He's the founding member of Chroma, the database that builds robust and reliable programmable memory for AI. Let's give the biggest cheers to our next talker, Li Chuanpei, and his topic, Fueling Innovation, the Power of Data in AI Applications. Welcome.
Okay, Chief, thank you for the introduction. Okay, and I'm Li Kuan, and I joined, I think, Chroma a couple months ago. I'm still new to Chroma. I think to get me started, I think I want to just say one thing. I think I attended the OpenAI Dev Day last year. I think one takeaway of the Dev Day is that although the large language models become better and better, and also the people building fine-tuning models, and they also say that retrieval is a big part of the stack if you really want to build a language model powered application in production. So I think this is kind of like Chroma's vision. Chroma want to be the retrieval for large language models. It's not only a vector database, and I will explain why. So before I talk, I want to show some of stats of Chroma. So Chroma was launched on February 14th, 2023. It's a Valentine's Day by chance, so we didn't like launch it purposely. We were planning to launch one day before, but then there are some bugs and we kind of delayed us launch one day, so it's accidentally the same day as Valentine's Day. And then it take off, and now I think it's already over a million monthly PyPI installs of Chroma. And then right now, I think it's over 1.2 million unique machines running Chroma each month. And that translates to 30K to 40K, kind of only part of the data, because not all the Chroma open source users are sending telemetry to us. This is part of it. It can be more than that. It also has been used by more than 12K open source GitHub projects. And we're a pretty small team. And currently we have a team of 7, and we have the maybe number 8 starting in a couple of weeks, and we have over 100 open source contributors, and we have over 10K GitHub stars. So I think what is the relationship between like retrieval and language models? I want to quickly recall. Basically, language model is something you can ask a question, and the language model generates the answer. And basically, it generates answer using a model by compute a conditional capability of generating the next token, and it generates bound one by one token a time. So that's why we call it auto-regressive model, meaning that the next token generated is conditioned by the previous generations of the tokens. What are the issues with language models? It's basically store the knowledge in their parameters. There are nice properties of that because you can get a compressed view of the knowledge using the parameters, although they have lots of parameters. But comparing that with the knowledge we have in the world or on the internet is still a pretty small subset of parameters. But there are some like limitations of this approach. Basically, the model cannot be really updated in real time, and it cannot be updated deterministically because machine learning or like kind of like optimization problems. There are some randomness built into the training process of generating models. And also, you cannot really say that why something not work. And I think one of the interesting thing you can see from the paper is that there was a section called "Why This Work," and some author just say that because of nature of how we solve the problem, I don't know how this works. This is kind of nature of the machine learning, and also because we force the language model to give us something, for any questions. If there's something they don't know, they just are forced to generate something, then they just hallucinate, meaning that they'll generate something that it doesn't really make any sense. And then I think 2 years ago, there's a paper called Retrieval Augmented Generation for Knowledge-Intensive NLP Tasks. Basically, the idea is that how about like we compare the parametric approach and the non-parametric approach, meaning that we use a model together with some like documents, basically some expert curated documents to assist language models so that they can provide more accurate answers. And the idea is basically like instead of the query you want to send to a language model, instead of the question you want to send to the model, you use a question to retrieve a set of like documents which are relevant to the query, and you feed them together into the language model. And the hope is that with this additional information, you can generate a more accurate and a better result for the specific question. And then what this actually shows is actually better than pure like text-based search. I won't go into detail about if you combine the, regular, you say text-based retrieval plus embedding-based retrieval, you can actually get better accuracy. Even you give like a very small amount of training data, or a very amount of like embeddings to the language model or to the retrieval process. So let's review a little bit on how this retrieval using dense vector works. It actually has several steps. First of all, is the chunking, and then you choose the embedding function to. So basically, what does chunking mean? You give a list of documents which are potentially pretty large, and with each document you chunk into fixed size, potentially similar to probably the window size or the context size of language model. And then for each chunk, you choose the embedding model and then create the embedding model for it. And then you create the scalar index, meaning the text-related index, and also the vector index. And then you do query on those, and then probably do some re-ranking to get the actual result. I think the key takeaway here is that in each step, there's quite a few experimentation you have to do in order to generate the desired result. I think there are actually two kind of like interesting observation I had by talking to our users and potential customers. It's really like, okay, people right now is really prototyping, especially prototyping the retrieval augmented generation application. And those prototyping is really easy with like the vector databases and also the developer framework like LangChain and LlamaIndex. They're pretty easy. You can build that. I don't think you can build it. You need really a week. You could build something within a couple hours. But the other observation is that for many enterprise users, they also claim that if they really want to build a production-ready application, there's a lot of tuning and experimentations are needed in each of the steps, including the chunking embedding and building different type of like indexes and different type of re-ranking models so that they can have a production-ready system. Not to mention that they also need to build fine-tuning models iteratively to in order to generate a reasonable kind of application with acceptable recall and precision. So there are actually two kind of like relatively conflicting observation. So that means that vector search alone is only part of the solution. And as a Chroma, as a vision, we think that we want to make sure the whole process from the idea to productization, and we want to build tools for the whole process instead of like users need to look for point solutions at different stages. Those tools including like how like providing users like different type of chunking strategy, embedding strategy, as well as different re-ranking models, and provide tools and APIs for users to feedback their result to Chroma, and also provide tools to evaluate their result by different metrics. That is like chroma switching, basically. And I want to quickly go over potential use cases with language models and retrieval. I think the first one is very common. Basically, chat your document application can build a internal knowledge base or chat applications with language model and provide them some of the data you have, like internal knowledge base or something you only know, right? And the second type of application is there's autonomic agents. They basically interact with the external world and learn some of the kind of like skills. For example, there can be the case that you want to build a agent for your internal operations, DevOps, and they know your deployments and they know your kind of usage behavior. You can ask them to do some capacity planning and the sort of like cost reduction, and then they can provide suggestions to you based on their knowledge about your system, and that kind of knowledge can also saved in Chroma. And here's also a paper by university, I forget which one, but they kind of using Chroma to basically to see how whether the player of the games can learn skills, and they basically play Minecraft and they basically learn the skills, and those skills can be saved in Chroma, and they can further use those skills to learn new skills, and which is very interesting. And the third application is like I would say Copilot or the prediction or document generation for your wikis like Notion. And then they basically given your input, and then they will provide some suggestions, and you can decide whether you want to accept or reject their suggestions. And this is third, like kind of like a human's loop for various tools, like auto completion and predictions for something. So those are three types of use cases. And by analyzing the usage pattern of our open source users as well, talk to our prospects, here's our understanding of the workload shape, I think, which is very different from the vector database, actually traditionally built vector database kind of like application. Those applications focus on really recommendation, ads, and those are very large index, potentially serve millions or even more QPS. And for the language model powered application, which needs long-term memory, I think the QPS is pretty low because usually it's kind of like a human in the loop, kind of like interaction. And we also need some real-time data because something, if you think there's answer is not that good, you want to feedback and adjust your pump so that the future response from language models will be more accurate. And there's also the scale is much smaller. And then there are frequently updates and deletes of the data. And there are potentially many individual indices. Potentially each user can actually can build index. It's like the GPTs from the OpenAI. You can build your own application, and potentially the index is quite small. And if you want to host those many indexes, this can be many indexes in the system. And we also want to, if you really want to build a serious application, you want the recovery to be big. And the final thing is that those vectors for language models are bigger, especially the dimension is bigger than the recommendations. Typically, you have like over 15K dimension vectors. So these are kind of like a difference from the traditional recommendation system, kind of like vector searches. Okay, how do we solve the nearest search problem in general? When the scale is small, you can just use brute force. But the brute force is very, very time consuming at large scale. Then people kind of like building a approximate neighbor search we call ANN. I think this is not new, but there are basically two types of algorithms. One is built based on inverting indices, and the idea is pretty simple. It's basically you partition your vector into different parts, different clusters, and then you compute centroid over data and assign the data points into a given centroid. And also you kind of like in the meantime apply a technique called product quantization, meaning that you kind of like reduce your size of your vector by dividing your vector into chunks and assign each chunk of the vector or each part or each part of the vector, which we call subvector, to its centroid, and then you can potentially save some spaces. This is one approach of solving the problem, and because during the retrieval you basically search not search all the data, but only search for the sum of the nearest centroid and then look for the point within those centroid instead of search the whole spaces. That kind of intuition is very straightforward. The second approach is building a graph, and the graph is basically you can capture some the short range and also long range kind of connection between the points so that you have a better chance to get the result you want, thus higher recall. So as I mentioned that for the inverted index approach, basically you compute the k-means, generate centroid and the quantite, and then assign the points to the nearest centroid. During required time, you find the closest centroids and compute the distance to the centroids. And then you have to re-rank because for the centroid, because your data is product quantized, it's not full precision. It's better that after you retrieve result, it's better to rank to get the final result. And I think one of the challenges of this approach is that because you cannot partition the data into subspaces, and in order to have a reasonable recall, you have to overquery a lot in order to get a reasonable result. It's not surprising to see that even you want the top 10 result, the 10 closest result, you want to query maybe tens or 100 times of the data from the inverted index in order to get a reasonable recall. And the second approach, as I mentioned, is a graph, and the graph has some heuristics to allow build some long range connections so that you have higher chance to not stuck into one of the kind of part of the space. So you have higher chance to get the result you want. I think here the important takeaway that is a graph. It has a nice property, it has some long range connections so that you can have higher recall, but the challenge is that the graph is not great for disk because it's basically a random access across graph when you do the graph search. And then in order to get a reasonable performance, you have to basically save the whole graph in memory. And also a lot of delays can degrade the graph. Then once over 20% of the data has been deleted from the graph, you basically need to rebuild the graph. And as I mentioned, the challenge with the inverted index is that the recall is not as good as the graph-based. And then you have to overquery in order to have a reasonable recall. It's very hard to twin, and also you have new data ingested in your system. Because you only do clustering once, there can be drift. Basically the data is, so that's a challenge you have to solve. Then how do we think about this problem at Chroma? We think as the following. We basically look at a lot of literature about solving the approximate nearby search at scale. And here's our thought on this. We take ideas from the paper of SPAN and also AD sampling, and I will briefly go over them. And the idea for SPAN is also very simple. Basically, we store the centroids as a HNSW graph, okay? And also we serve the possibility list for each centroid on disk. And here the difference is that we have very high centroid count. It's basically we take 10%, 20% of total graph as centroid. And meaning that the result is each possibility can be very small. That's kind of the result of high number of centroid. And then we assign point to not only one centroid, we assign to multiple centroid if they are on boundary, meaning that if a point is closer to 2 clusters, we'll assign this point to 2 clusters instead of 1 cluster. And this allows us to build some like longer range collections between the points. And also, in order to now to assign a point into two clusters which are too close to each other, we also skip some clusters if two clusters too close and the distance between the point to the cluster is bigger than the distance between two centroid, then we skip them. And the intuition is that we'd rather like to give the chance to search more different direction, more distinct, like space, instead allowed to search the space which are very close, which already means that the two very close clusters, they probably all will have the same recall. And during the query time, we'll not query all the posting lists because there are many of them, because we have very high centroid count, and we only search the posting lists which are very close to the closest centroid to this point, so that we prune a lot, and we also still get a very good accuracy. And another technique we'll be using is called eddy sampling, and I think the one observation is that a lot of time spending on the graph traversal is to see whether a point will be in the final result, which means that we'll be rejecting a lot of points based on the distance comparisons. And here the idea, and you can see from this graph that I think over 60% of time for HNSW time is spent on rejecting candidates, and for the IVF, which inverting index space, over I think 80% is spending on that. And I think the intuition that if we can find an algorithm to reduce the time to reject candidates, that'll be faster. And the idea is that we can project the dimension to a lower dimension and check using hypothesis test to see whether this lower dimension is will reject or not. And by running that hypothesis test, we can quickly figure out if a point should be in the candidate list or should not be candidate list. And this can basically reduce the time a lot, but still preserving the recall. Okay, and here's the chroma index. I think we will be basically divide the data into real time, and here's darker segments. And the real-time data will be stored in the HNSW graph, and also we will compare the historical data into inverted index like the Spain, and query with the eddy sampling with big store centroid in HNSW, and the posting list can be stored separately to allow for separate storage and compute. And this and the result is that will be having much less memory footprint into the system, but still preserving a good recall and saving a lot of computation cost by using the eddy sampling. Here, the algorithm part of the talk, and we'll quickly go over the architecture part of it. As you know, Chroma, when it launched, it is single node version, and the architecture is very simple. It contains clients, and then it has a founder server talk to different type of indexes. You can think about metadata index as the traditional scalar full text search based index, and the vector indexes are the HNSW graph, and they basically are local disk based. And the distributed data is also very simple, and the change are basically we have control plane, we have systemdb and the coordinator, and systemdb basically served as the catalog. You can think about it, save the information about the collections and the tables in the system. Also as a tenant in the system, and for the data plane, it basically has a log for durability, and then we have indexing node build indexes, we have query node serving queries, and the data in Chroma all can be saved in S3 for cost and durability, as well as providing serverless semantics, basically allow you to serve many collections in a single cluster. And some design principles is that we need to leverage this ecosystem when possible, and we build critical capability ourselves and reduce global coordination. And I think that's the majority of our talk. But before I finish, I think I do want to talk about a little bit about Chroma's vision and also the roadmap. I think our observation is that retrieval is not sufficient in order to build a end-to-end production-ready language model-powered application. Actually need quite a few iterations as well as changing your business logic as well provide more data. And I think we as Chroma want to build tools allow you to do this. Meaning that for you to easily try different business logic by providing feedback of the throughput and providing easy ways to store data with labels, meaning that not only the data, but also data with like feedback on whether this data works well or not work well. And we also provide tools for you to iterate how you iterate and observe the result with the different iterations. And what we are going to build is not only the vector search APIs, but also APIs like for you to describe a pipeline so that we can help you to experiment the different embedding, chunking, and re-ranking strategies for you. And we also provide feedback endpoint for you to save the feedbacks to Chroma. And then you can later use those feedbacks to generate better results. And also you can find your rebandings based on the feedback. And also you allow you to try different chunking strategies and the re-ranking models. And that's all. Thank you for your attention. Yeah.
All right. Thank you. This presentation was so impressive, and I've learned a lot from it. And I think it's a little bit hard. So a lot of the audience asked, will we share the recording of the event or not? Yeah, we'll share it, and you can just look at the repeatable. So what the Genpei shared is cutting edge. So that's why. So I've received tons of the questions from our audience. So let's go into the first one from So. What can we do to prevent duplicate content being loaded? Where is that? Sorry. Mean it say we had 10 PDF uploaded today. Then in 1 month added 10 more PDFs, and one of them is a repeat from the PDF already loaded. So how to avoid this? So from my perspective, I think if you can just hash that and you can use the empty file and you can just know exactly the same, but maybe they change a little bit so you cannot detect for them. So what do you think, Alicia?
Yeah, I think it really depends on your goal, right? So depending on your goal, right? I think Chroma do provide we call it the each record has a user kind of like ID. User submitted ID will basically do duplication, dedupe based on that ID. That's one way to do it. And the other way to do it, depending on your intention. As I mentioned, Chroma is not only a vector search engine, it also has a lot of metadata you can build for each record. And for each record, you can annotate the record as the time or as your purpose, right? You can basically design ways so that, for example, this PDF I want to use for task A, right? And then I can annotate the metadata as like task A, and then when you retrieve, you can just retrieve all the embeddings with task A, and then the other day you add another 10 documents, but you want to use task B, you can then annotate in the metadata for each record as these are used for task B. Then you can do something about it. Really depending on your intent. There are multiple ways to it. There are simple ways like system-wise, you can just dedupe by ID, but there are also, if you want to really keep duplicates, but for different purposes, you can do that by annotating the documents with the metadata.
Yeah. Got it. Yeah, totally makes sense. So okay, I don't know if it's answer your question or not. So But yeah, let's move to the next question. Next question would be, among all of the database available in the market, so what makes Chroma special?
Yeah, I think the Chroma's vision is really like we will be helping I'll say the developers, especially AI developers, to build application. I think we observe that the vector search retrieval is only part of the whole pipeline, and also only one tool people use to build application. So we really think that we will try to build a whole solution to help people solving the problems by helping application developers to build app from the idea to production. So that's our vision. As I mentioned in the slides, we want to, I think, instead of focusing on vector search, we also want to build tools for you to provide feedback, tools to help you experiment with different embedding chunking strategies, and APIs for you to hook different type of like re-ranking models. And we'll build them for you so that you can easily try ideas, validate your result, and then run many probably experiments in parallel to quickly figure out which one is the best way for you to go production. Yeah, I think that's a big difference from us and other probably vendors. Yeah.
Got it. Got it. So not only just the vector database, but also some embedding and retrieval to solve all of the questions from the retrieval solutions. Got it. So yeah, thank you, Li Juan. And it's so information and so much information. And I think time is running up. So if you have any questions, you can reach out to Pei through his social media accounts. And next, it will be me. I will introduce a way to build your own GPT marketplace. So, Yuya, can you play it?
Want to have your own GPT trending list or marketplace? Okay, let me give you a free GPT to use it. We collected 50,000+ of customer GPTs with ID, name, author, URL, description, and conversation count. And how to use the dataset?
Why don't you ask the magic conch, Squidward?
Let's ask the GPTs itself. In today's video, I will show you how to build a GPTs marketplace by GPTs and database. Hey developers! Do you want to build your own powerful GPTs that can get more information? For example, the GPTs marketplace. Today we'll dive into how the latest GPTs can load data from your API. And we will work through a typical GPT that can uncover trends in GPTs itself. You might be surprised at how useful it is. And our superheroes, the GPTs. Needless to say, nobody doesn't know it. This advanced model can analyze tests and help us to find trends and patterns. The only thing that we should do is to give the right information to your GPTs and give some prompts. So check this out. We've got 4 default options ready to roll. Let's walk through them one by one. Feeling lucky today? Give the first one a shot. It's randomly select 10 GPTs for you. If you are looking to snag some of the hottest GPTs, it will hook you up with options based on how many conversations they've had. Also, if you are keen on searching by keywords, you're all set. Like if you search for JavaScript, it will line up some GPTs related to whatever keywords you throw in. Looking for top authors? Just type top authors into the input box. And if you are aiming to filter by language, go ahead and search using a language code like JA, which means Japanese. I will put this GPT's link into the description. If you just want to use it, you can click it and use it directly. But if you want to make your own, please keep going with me. With our customer-built interface, we can make GPTs to call our own API to get GPT's data. Well, how did we do that? How can the API connect to the GPT? First things first, we already maintain a set of GPT's data in real time. You cannot do it without any effort. And then, set up an HTTP API. I will show you how to build it. You can build your API with a service. But to simplify, I will open TiDB Cloud Data Service and make an API within 30 seconds. For example, I will set the API name and path as /demo and deploy it. That's it. You already have a published API. Our TiDB Cloud is also optimized for GPT configuration. Just click on Get Configuration, then create an API key. After creating it, move to the Create New GPTs section. In the Config tab, scroll down to the end and you will find Create New Action. I won't go into the other configurations above. You can complete them step by step using the Create tab on the left. Here for authentication, choose API key. We go back to TiDB Cloud and copy the base64 encoded API key. This is required by OpenAI. Okay, save it. Then, for the schema, we can also import it online. Go back to TiDB Cloud, copy the API specification URL, paste it, and click Import. It will recognize your interface. We only create one just now, so only one interface is identified. If you had to create multiple, then multiple APIs would be listed here. Click on Test and authorize access. Okay, this completes the connection. You can just save it up. See, with GPTs, we can leverage itself to make its own marketplace. Amazing! And we can use API in our GPTs very easily. Got your own ideas for GPT-powered apps? Share them in the comments. We are building a community for developers pushing the boundaries for GPT innovation. If you have more fun usage for this dataset, welcome to send some comments below. Want to know more about these technologies? Subscribe to us now. Thanks for watching and see you in the next video.
All right. Okay, if you have any questions, you can reach out to me through my social media accounts, and I will be more than happy to answer your questions. So, Fox, next we will exploring another groundbreaking application of AI. Get ready to witness how CrowdSnap is writing the rules of the market research industry with the AI and data revolution in action. How CrowdSnap transformed the market research by Hasida. Welcome.
Yeah. Hi, hi everyone. Thanks for having me. Thanks, Cheese. Yeah. I'm Hasida from CrowdSnap.ai. This is today's agenda. We will be explaining a bit about our company and the product and challenges, and then how we overcome the challenges through our solution, and a little bit about the future roadmap of our product. Let me dive into the product slide. CrowdSnap is a consumer research platform that is B2B focused, and we deliver it as a software as a service platform. And we are targeting brands, market research companies, and independent researchers who conduct researches. So what we actually do is transforming, collecting industry data, and then we process, analyze them, cleansing and verifying, and preserving the privacy, and then we find the trends, valuable consumer insights for the brands or companies to take their decisions. So right now we have we just started sales very recently, and already we have confirmed clients who are already using our platform in countries like UK, Singapore, and Sri Lanka. We are based in our technical team is based in Sri Lanka. Yeah, this is our product value propositions. We offer enhanced quality for the data. We ensure the speed of delivery as competitive as possible. And also we have certain components that ensure the transparency of the data, how the data being flowing through our platform, and we ensure the privacy. How we do that is we use publicly verifiable consumer insights through a blockchain platform, blockchain layer. And also we have certain privacy preserving components with the zero knowledge computing layer that only the participant can see their words. So the computations happens in the zero knowledge layer. And real-time analytics. So we are a data platform. Our speed of delivery is essential to keep the quality and ensure the data is fresh as possible for the end users. And we are AI integrated from starting from the research, analytics to the decision support, C-level executive reports. We are integrating AI where necessary and provide the true value proposition for the end users. And our focus is to make it diversified as much as possible into like do it yourself, like DIY kind of a platform, because there are certain industries like researchers have no knowledge about. So in that case, we like to make our platform in a way that everybody can conduct a research and we provide assistance. Well, this slide is more about the data and the AI combination, how we leverage powerful language models to create intelligent data gathering tools. The key component in the successful research is how you tackle the survey, your research objectives with your data points you gathered from the market, right? So we have certain data gathering tools. We process videos, images, as well as data, text data. Most popular data gathering tool to grab the direct data is surveys. Our surveys are intelligent. We use natural language understanding to choose the questions between users based on how they answer. And our knowledge base is powerful up to the extent where you give a topic and related context, and our platform is capable of creating a survey for you that is intelligently branched between questions and adapting based on the user's behavior. And then analytics of the data. Yeah, this is data analysis is very important, and provide and find the required trends like the survey market research is expecting, right? And we use AI algorithms to analyze vast data sets effectively, not only the data that we gather, but also we provide an option for them to bring the data like, sales data, customer data, and history data, and then find correlations. So researchers have a capability of finding relations between consumer sentiment and how the sales been done in the past or in the particular time period, like whether it's negative or positive, and whether there's an impact between these things. And then we provide comprehensive report for the C-level executives that contains all the visuals that requires for them to understand how the data been collected, how the market behaves, and what's the consumer's behavior, and also decision summaries, identified trends, and key highlights about the survey. We do that through merging different data sets from different industries and applying algorithms on top of them. Yeah, this slide is more about challenges we faced throughout our journey. So we are, as a data platform, I have to mention like regulatory is number one, because we cater the clients from all parts of the world. So there are some trade barriers, trade agreements, like you can't keep your data in a single location. You probably have to move to their own regions, like based on the trade agreements. So we wanted to find uncomplicated storage strategy that is hassle-free as possible, where we can focus on our product and the infrastructure is capable of helping us. And then scalability and flexibility. So of course, we are running a service like when it comes to global service, likes of 30,000, 10,000, probably lakhs of users accessing our service in a short time span. So our platform should be able to scale based on the load and quickly provisioning the resources and provide the necessary flexibility and adaptability is a must for a platform like us. And then achieving the quality of the data standards. So I will dive more into that in next slide. So basically, we are trying to be transparent as possible through the blockchain layer, providing publicly verifiable information that based on the demand, as well as be very specific about the speed of the delivery. Because fresh data is the number one key factor in the successful research. So these are the challenges that we want to overcome to make our platform competitive as possible with the market leaders. And this was our previous architecture. As you can see, we were in Heroku. It's a Salesforce based cloud provider. And our reporting and analytical components are using our databases. We had a couple of databases for the transactional purpose, as well as keep the aggregates. Our aggregates are scaling because some services are really complicated with a large amount of data. So we had a data warehouse that contains multiple databases. And it was in the ClearDB component that is linked through the Heroku. Well, now this is the solution and the comprehensive architecture that we followed throughout our journey. In this box, you can see the first part is gathering the data and how we cleanse the data, and it's going through blockchain layer, hash the insights and putting them into the blockchain for the public verification if it is necessary. And then our data is moving to the analytics database and then into the reports. So in the top component, you can see we have merged the two databases into the single data warehouse using TiDB's hybrid transactional and analytical processing database. So in this case, we have simplified it like transaction and the aggregates, and the analytics are working in the simple single data warehouse. So that's simplified the process for us as application users, and it is capable of catering high volumes in a quick time. And we at the moment we have clusters created in East US, Singapore, and Europe, and based on the demands, that these are the areas that we have clients. So it was very easy to spin up the cluster wherever you have a client. We as a software as a service provider, we just provision the application through a cluster, and the cluster is spinning up like within 1 or 2 seconds. And we noticed significant improvement in our fresh insights, improvements in QPS, and the scalability being simplified, and hassle-free way of infrastructure. So it was easy for us to manage our application on top of this infra. And this is our future roadmap. We already started global expansion. Like we made partnerships with some research agencies in UK, and we are discussing with some of them in different countries as well. So we are planning to use continuously use TiDB's multi-region and multi-cloud support structure that ensures low latency access for the users distributed across the globe. And also as a technical component, we are planning to use predictive analysis for integrating predictive analysis more into our data and provide a better insight about the future for our users. And we hope to use the scalability and the computing power offered by the TiDB for that. And finally, we are a continuous learning and feedback platform as we are using AI. So we need to strengthen that area in terms of data gathering from feeding the data from multiple segments. When it comes to research, there are like dozens of topics, and that is an ongoing subject. Like research is not that you just execute a research and then that is the data set that can give you decisions, but it's not like that. It's an ongoing task. Like you need to continuously grab the data. And yeah, so that's about our product and how we overcome some of the challenges through our journey. Our platform is already accessible for the users in the globe, and most of the advanced features are free at the moment. And feel free to onboard into our platform and start using it. And you can reach to us through our email, public email, that is info@crowdsnap.ai. And feel free to contact me in LinkedIn for any technical queries. I'm happy to answer. Yeah. So any questions? I'm happy to answer them.
Yeah. So this presentation is very insightful, I would say, and Hasta gave us a new perspective on practical examples. So do you guys have any questions? I got one. How can startups prepare themselves in tech stack setting to tackle the challenges posed by the era of AI?
Well, that's a good question. So I think you have to be laser focused on what your consumer requires. Number one key is when you use AI, right? You have to identify the applications of AI, where how that application provide a true value proposition for your product, right? So once you identify the applications correctly, you can probably start with the easiest approach like OpenAI. No need to complicate it too much, and then provide the value. And then when it's come to the point that you really need the scalability and you really need to bring your more and more data and storage, and then you have to go to those those directions. So it's always better to have a better infrastructure that is capable of handling the loads, and as a product that has to. So eventually you need to sell your product, right? So in that case, you have to have a competitive price point for the users and capability to handle the load. So it's very important to compromise without compromising those things. Very important to have the things ready at the very competitive stage. So having a better, so number one is identify the use cases. Number two is wait till it really scales. And number three is finding the correct infrastructure and tech stack to cater that. Yeah.
Got it. Yeah, that's so cool. So you can just demonstrate that and do it step by step. That's very good. And you guys have any questions there? Okay, I don't see more. So if you have any questions, you can reach out to Hasida through his social media accounts. So yeah, there's one. What is the purpose of the blockchain in your I assume in your data pipeline?
Yeah, so that's a good question. So we try to be transparent as possible, where one of the use cases value USPs and the value proposition that they provide is the quality of the data and the transparency of the data. So our end users who access the data, our consumer insights, can verify our flow, our process, how the data being transformed in the process throughout the journey. So we use blockchain for that. Blockchain is, it's a immutable ledger. When you hash and put something data into that, so you can't compromise that. You can't change the data. So that provides the value in that.
Got it. Yeah, that's so cool. And you use blockchain in another way, aside from the Web3. Yeah.
Yeah.
Got it. Yeah. So yeah, I think the time is running up. So if you have any question, you can reach out to Hasida in person through his social media accounts and his cloudsnap.ai website. So okay. Then today's webinar shows us how data is a fundamental infrastructure of AI, right? So it can truly bring innovation to the world and transform all of the industries. So thank you for joining us in this amazing journey, and let's step into a brighter and more informed world with data. As we wrap up today's webinar, let's welcome Shi Xing, our product manager of TiDB Cloud Serverless, to announce our database new AI feature. Sorry.
Thanks, Cheese. I think our feature is actually the future. So thank you for having me here. Hello, everyone. So this is Xing, and the product manager of TiDB Serverless. I learned a lot from today's conversation from our amazing partners and customers. So at PingCap, our mission is always to empower developers, enterprises to innovate with the speed, agility, and scale, especially in the year of AI. So let's first talk about what we have today. TiDB Serverless is MySQL compatible database, allowing for seamless integration with your existing applications and systems. When you sign up TiDB Cloud, you can start for free. Everyone gets up to 25 gigabytes free storage. It can scale down to 0 and scale up to support 1 million QPS workload. We have customers migrating from other database service to TiDB Serverless, and with our pay-as-you-go pricing, they have saved up to 85%. Not only just for more cost efficient, we have a list of great features innovated together with our developer community. Data branches, it's like the version control of the database, allowing your database seamlessly integrate with your Git workflow. Data service, it provides secure HTTP endpoints, and you can interact to TiDB Serverless using simple HTTP endpoints, removing the need to manage persistent connections to the database. HTAB, this is referring to our unique versatile storage engine that makes you run both transactional and analytical queries in one TiDB database. Chat2Query is our AI assistant who makes you can interact with your data in just natural language, making complex queries as simple as having just have a human conversation. And all of these are built on top of our open source foundation with over 35,000 stars on GitHub, which shows our dedication and commitment to transparency and community-driven innovation. And most importantly, this is important, today, we are introducing vector offerings into our product family. This is for storing embeddings powered by our distinctive storage engines. We also implemented the similarity search indexes and the algorithms based on our smart optimizer, offering you optimal performance for your AI applications. So with vector search in TiDB Serverless, no matter what AI applications you are going to build, you can now store and retrieve vector data through MySQL interfaces. Your transactional workloads, analytical data, and embeddings now are in just one database. No more silos, no more jugglings, no more management between different types of databases. Everything you need for your AI application is right at your fingertips in just one place, ready to accelerate your innovations and deliver performance at scale. We believe the database you are using today is the best vector database. And this is only the beginning. I'm thrilled to invite every one of you to our Vector Search Private Beta program. Be one of the pioneers to explore data plus AI at scale with us. To join the program, visit tidb.cloud/AI or scan the QR code showing here. Or just send me a message or get in touch with the host coordinators of the webinar today. We are excited to see how TiDB Serverless Vector Search will empower your data plus AI journey. Your insights will help us refine the database platform that's set to revolutionize the industry. All right, that's my part. Thank you for staying with us till the last minute. Yeah, back to you, Chase.
Yeah, thank you guys. And I think that's all. And maybe see you in the next webinar. Yeah, see you. Thank you. Bye-bye, guys.